In this video, we will learn to add and subtract rational expressions that do not necessarily have the same denominator. So when I use this phrase rational expressions, that refers to fractions that can have polynomials in the numerator or the denominator. Now, just like in elementary school when we learned that 1/5 plus 2/5 is 3/5, we know that if we have like denominators, we can just go ahead and add the numerators and keep the like denominator. It's the same thing no matter how complex the fractions get. So problem number 1 is relatively easy because we already have like denominators. That means I can go ahead and write the denominator one time, and I can go ahead and combine the numerators. Now, because it's subtraction, we can add the opposite. So that's kind of the best way to look at it. Change it to an addition problem and make this a -3. Now we're just combining like terms. There are no like terms, so we just have 7w minus 3. Now this trinomial is the type of thing that often factors, so let's try to do that. So we have 7y minus 3, and the denominator, w squared, that would factor as w and w. 3 would be 3 and 1. To make -4, that would have to be negative and negative. Now, there is nothing that I can actually cancel out. If somehow we had 7w minus 3, I could cancel out the numerator, and I'd have 1 over w minus 1. But it's just w minus 3, so there's absolutely nothing I can cancel out. So this is my final answer. And in this form, it's easy to see what the restrictions are. W cannot equal 3, because that would cause this to be 0. And W cannot equal 1. Alright, that's the answer to number 1. Now, problem number 2 is a bit more complicated because the denominators are not the same. So what I need to do is make them be the same. And I can do that by adding additional factors to either side to make them the same. But first, let's factor and see what we have. So this trinomial looks like the type of thing that will factor. So let's see, y squared is y times y. 18. That could be 3 times 6. And if I make them both addition, that will give me 9 in the middle. Alright, so here I've recopied it so you can follow clearly. All I've done is I've factored this so far. Now, look and see, we want the denominators to be the same. So far, they both have y plus 6 in common, so they're halfway to being the same already. We just need a y plus 3 in the other denominator to match the one that we already have. So I can go ahead and put y plus 3 over here. Now, if I just do that, I've completely changed the value of the problem. Normally that would not be okay, but it will be okay as long as I'm careful to do the same thing to the numerator. Alright, you see how y plus 3 and y plus 3 would cancel each other out? So that shows you that I'm not really changing anything. Now, be careful. If I'm going to put anything else up in the numerator with the y minus 4, I really should put this y minus 4 in parentheses. That will help remind me that to get rid of the parentheses, I need to multiply. I need to double distribute this. Alright, and in fact, let's go ahead and do that now. So if I multiply this out, alright, so I'll have y times y, that's going to be y squared. And then y times 3 is 3y. Alright, and then if I do negative 4 times y is negative 4y, and negative 4 times 3 is negative 12. Okay, now you see I've got the like terms here in the middle, so that's going to leave me with y squared minus y, alright, minus 1y, or minus y, minus 12. Alright, so that's what I have in this position right here. So I'm just going to recopy the rest of the problem. Alright, so here I've recopied the problem showing what we have so far. Now, we have like denominators. It doesn't matter that here I have the y plus 3 first, here it's second. These denominators are the same. So it's time to put the two fractions together. Notice this is a subtraction problem, so be careful. We've learned that the easiest thing to do is to change this to an addition problem and take that negative sign and distribute across the numerator. So that's going to make this negative y squared, positive y, positive 12. I'm just changing all the signs. If I do that, I can just easily combine like terms. Okay, so my denominator is going to be this common denominator of y plus 3 times y plus 6. There's my like denominator. Now I'm combining like terms just straight across here. What do I have? Y squared and negative y squared, those are like terms. Well, those are just going to cancel each other out. Alright, 1 and negative 1 is 0. So these are gone. Y does not have a like term. There are no other y terms, so I'm just going to bring down y. And then that leaves the like terms negative 6 and positive 12. Those go together. So that's going to give me positive 6. So this is what I have so far. Now, it would be a good time to show what the restrictions will be before we cancel anything out. So I know that y cannot equal negative 3 because of that, and y cannot equal negative 6 because of that. Now, the y plus 6's, I have one in the numerator and one in the denominator. So those are going to cancel out. Alright, those cancel out. So all that's left is y plus 3. Please be careful. This is a common mistake that I've seen. Everything canceled out, so it is tempting to just write y plus 3 as your answer because everything else canceled out. But notice where the y plus 3 is. See how it's in the denominator? So in my final answer, y plus 3 still needs to be in the denominator. To sort of hold the place, we're going to put a 1 up here. So the final answer is going to be 1 over y plus 3. And these are my restrictions. Alright, number 3. We need to make these two expressions have the same denominator. Right now you can look at this 7 as being 7 over 1. Now I'm actually going to spread these out just to give myself some room. So what I have here is 7 over 1, and I'm going to leave myself some space, and then I have my minus 4y over y plus 5. Alright, I just basically recopy the problem. Now I need the denominators to be the same. On the right hand side I have y plus 5, so I need to have y plus 5 on the left hand side as well. So I can just write in a y plus 5, okay, in this denominator, as long as I put the same thing in the numerator, y plus 5. You can see that I could cancel them out at any time, and that lets you know that I'm not really changing anything. So now they have the same denominator. This 1 is no longer really doing anything. All right, 1 times y plus 5 is just y plus 5. So these are now like denominators. So I can go ahead and do the distributive property here. And also, there's nothing to do here. So it's a subtraction problem. We've learned that we can change it to addition and put the negative here. So I will just go ahead and do the distributive property to get ready to combine like terms. So my distributive property gives me 7y plus 35. And then here I have minus 4y once I combine my like terms. And then in the denominator, I have the common denominator of y plus 5. So my like terms are the 7y and negative 4y. So that's going to give me 3y. So I have 3y plus 35 over y plus 5. Alright, there's no common factor. There's nothing I can cancel out. Notice I cannot divide the 5 into the 35 and make 7, or I can't cancel out the y's. I can't cancel anything that's connected by addition or subtraction. So this is my final answer, and my restriction is that y cannot equal negative 5. Alright, because of this denominator. Okay, these denominators are different, so we'll have to be careful about that. Let's go ahead and factor these so we can see what we are dealing with. So let's see, 2x squared. That can only factor as 2x and x. 5 can only factor as 1 times 5. Now, inner plus outer must equal middle. Right now, inner I have 1x, outer I have 10x. I can make the signs be whatever I want, but there's no way to get a negative 3 out of it. So let me try putting the 5 first and the 1 second. Now, inner plus outer must equal middle. Inner I have 5x, outer I have 2x. If I want this to be negative 3, I need a negative 5 and a positive 2. So there's my negative 5, and this will give me the positive 2 outer. Also, negative times a positive is a negative, so that's how you factor this trinomial. Now look at the second trinomial. 3x squared can only factor as 3x times x. 2 can only factor as 1 times 2. Okay, I'm sort of looking ahead, and I can see that putting 2 here and 1 here will help me. Inner plus outer must equal middle. Inner I have 2x, outer I have 3x. I can get a 5 by just letting these be positive. So that means both of these will be positive. And a positive times a positive is a positive. So now that we have factored everything, I'm going to recopy the problem to make it easier to follow. So let's see. I have 3x minus 4 over 2x minus 5 and x plus 1. And then minus 4x plus 3 over 3x plus 2 and x plus 1. Do they have anything in common already? They both have x plus 1, so I don't need to bother that. But the left side has a 2x minus 5. The right side doesn't have 2x minus 5, so I give it 1. So I will write in a 2x minus 5. So now they both have 2x minus 5. This is only okay if I also include 2x minus 5 in the numerator. That way they would actually cancel out, so I'm not really changing anything. It is helpful to put the 4x plus 3 in parentheses now, since it's no longer the only thing in the numerator. It will help me remember to do the distributive property twice. So they're almost the same. Now both denominators have 2x minus 5 and x plus 1. However, the right hand side has a 3x plus 2. The left side doesn't have that. So I will give the left denominator a factor of 3x plus 2, which is okay as long as I put it in the numerator as well. And again, now that I've put something else in the numerator, I should put parentheses around the 3x plus 4. So I need to double distribute this and this to see what we actually have. I'm going to try to squeeze it in right here. Alright, 3x times 3x is 9x squared. Alright, 3x times 2 is 6x. Now negative 4 times 3 is negative 12x. And negative 4 times 2 is negative 8. Alright, of course we have like terms here that need to be put together. I think I'll do that when I recopy in a minute. So now looking at this, I'm going to double distribute again. So I've got 4x times 2x, that's going to be 8x squared. 4x times negative 5 is negative 20x. And then 3 times 2x is 6x. And 3 times negative 5 is negative 15. Alright, again we have some like terms right here that need to be put together. Alright, so I'm just going to recopy this to show what we have so far. So here's my like denominator, and I'm going to go ahead and copy this down, even combining the like terms. So I've got 9x squared, and this is going to give me negative 6x when I combine these, and there's my minus 8. Then over here I have that 8x squared. Combining these gives me negative 14x and minus 15. So now that I have like denominators, I can start putting these together. Since it is a subtraction problem, what we do is we change it to an addition problem, and instead we take that negative and we distribute. So I'm going to change all of these signs. So this will be negative, this will be positive, and this will be positive. Now I will combine my like terms. Alright, now that the denominators are the same, here's my like denominator, and combining like terms. So 9x squared goes with negative 8x squared, and that's just going to make x squared. let's see, negative 6x and positive 14x, that's going to make 8x. And finally, the constants. Negative 8 and positive 15 is 7. So we have this. Now that trinomial looks like the type of thing that we often factor. So I'm going to attempt to factor the trinomial on top. X squared can only be x times x. 7 can only be 1 times 7. If I make this a positive and this a positive, then I will get a positive 8 in the middle. Alright, 1x plus 7x is 8x. So it did indeed factor. Now would be a good time to say what the restrictions are going to be. I will have 3 restrictions from each of these factors. So x cannot equal 5 halves because of this setting. If I set this equal to 0 and solve, this is what I get. X cannot equal negative 1. And x cannot equal negative 2/3. Alright, I get that by setting each of these equal to 0 and solving. The numerator is irrelevant, just the denominator. Now I look and see, can anything cancel out? And I see I've got this x plus 1 in the numerator and in the denominator. So those will cancel out. But that's it. Nothing else cancels out. So the final answer is going to be x plus 7. That survived, over, now this is gone, so that's just going to leave me 2x minus 5 times 3x plus 2. So that is the final answer. All right, for number 4.